They're both odd number.
Yes, odd number. So this is related to the theory behind NMR. Let's find out. So you know that electrons in atoms, that pair up in orbitals, they have opposite spins, right? If pair up in orbitals, they have opposite spins.
Oh,
Yeah. And similarly, protons and neutrons in the nucleus, they also have opposite spins. So if a nucleus, it has an even number of nucleons, the spins can cancel out. But if it has odd number of nucleons, the spins cannot cancel out. So there will be a residue spin.
okay.
Okay, get it? Residue spin. Okay.
Y-
Can you understand this point?
Yes, yes, I understand.
Okay. So residue spin can cause a tiny magnetic field. In physics, electricity can cause magnets. So you can image this nuclear as tiny magnets, just like a bar magnet. Yeah.
Okay.
So now, yeah, if you apply an external magnetic field to the nuclear, then you will find the nuclei either parallel to the field, like this picture, or anti-parallel to the field. This is parallel. You can see north face to the source pole.
Yes.
And yeah, and this is anti-parallel. North pole face to the north pole. No problem here.
No, no problem.
Okay. And these two states, they have different energy. So this diagram, it shows the energy difference in anti-parallel state and parallel state. And now if you supply the electromagnetic energy just equal in energy to the difference between these two positions, the nuclear will flip between the anti-parallel and the parallel. Okay, so this is called resonance. Here can get it, resonance. This flipping we call resonance.
Why is it flipped?
就是它，我们是施加了这个电磁波、电磁能量 （electromagnetic energy）。有的原子核它会从 parallel 会 flip to anti-parallel，那有的原子核会从 anti-parallel to parallel，就发生了共振。
Oh,
So if you use computer and before the computer there is a radio detector. This is to detect the electromagnetic energy observed. So in the computer, there will be a carbon or NMR spectrum. So this is the basic theory behind NMR. And this will not be tested in your exam. You just learn the basic theory. And the most important thing is to learn how to interpret the spectrum. Okay.
okay.
So about the basic theory, did you get it? This is just a basic theory.
Yeah.
Okay. So let's learn the most important type of NMR, carbon-13. So we don't use carbon-12. Now you know that it's 12. It's even number, so it doesn't have residual spin. And carbon-13, although there is only 1% of carbon atoms are carbon-13, modern instruments are sensitive enough to obtain this carbon-13 spectrum. This is a modern NMR instruments, very huge, very large tank. Alright, so before we look at the spectrum, we need to notice that carbon atoms in different function groups feel the magnetic field differently. You can think why.
They have different electron density.
Yes. So nuclei are shielded from external magnetic field by the electron clouds around them. If more electrons around them, so they are better shielded. So if there is greater electron density around carbon-13 atom, the smaller magnetic field they will feel, and the lower the frequency at which it resonates. Let's see the spectrum. So spectrum, the vertical axis is energy absorbed, and horizontal axis is chemical shift. We use this symbol delta to stand for chemical shift, and its unit is ppm. This means parts per million. And did you notice the number on the horizontal axis? The number on the horizontal axis.
It becomes bigger.
From right to left.
Yeah.
Yes. So from left to right, it increases. From right to left, it increases. And here is number 0. This means the reference stand. We use which substance as the reference stand. This is TMS. Its structure is this. It's very unreactive. It's stable, so we use TMS and will not disrupt the signals. So we use TMS. It's tetramethylsilane. So its absorption, its chemical shift we labeled 0. And the difference between the resonating nucleus and that of TMS is labeled on the right. So in carbon-13, you can notice that the chemical shift ppm is from 0 to 200. Right here, 0 to 200. So this is about the spectrum. You need to notice the axis and the numbers and the reference stand TMS. And let's look at the example of ethanol. So ethanol is, you can firstly write its discrete formula or structure formula. It looks like this, right? CH3, CH2OH.
Yeah.
Yeah, so it has 2 carbon atoms. And these 2 carbon atoms, they are different. They are in 2 different environments. One is bonded to oxygen. This atom is bonded to oxygen, and the other carbon atom is bonded to carbon atom. It's away from oxygen. So you can look at the spectrum of ethanol. How many peaks?
2 peaks.
Yeah, 2 peaks. Let's see this peak. It's at 60 chemical shift, 60 ppm. This is due to the carbon bonded to oxygen. And another peak, it's about in between 0 and 20, almost 20. So this is due to the carbon in stage 3, is carbon. And whether they have different values, while bonded to oxygen, this carbon atom has great ppm value, great chemical shift. You can still analyze its structural formula or displayed formula. This the middle carbon atom, it's bonded to oxygen, right?
Yeah.
Yeah, so carbon and oxygen, which is more electronegative?
The oxygen.
Yeah, oxygen. So the more electronegative oxygen will draw electrons away from carbon. So this carbon is the middle carbon. It's de-shielded and feels a greater magnetic field, so resonates at higher frequency. So its chemical shift value is greater. It's 60. And the other carbon, this first carbon, it's surrounded by more electrons. So therefore it's shaded more and has a smaller chemical shift value. And during exam, you will be provided with this table. You can search for the different types of carbons, different chemical shift values. So you just know how to use it. You didn't need to remember these values. It's just a tool. Okay, so this is ethanol. 2 peaks for 2 different carbons in different environments. Oh, okay, so no question?
No question.
Let's see more examples. We can observe CH3, CO, CH3, and CH3, CH2, CHO, their spectra. And first, this is carbon-13 NMR spectrum of propanol. You can firstly search how many peaks.
It's 2 peaks.
Yes, 2 peaks. And relate 2 peaks to the display formula of propanol. You can find out why it has 2 peaks.
There's 2 types of carbon.
CH3, CH3, they are the similar carbon environment.
Yeah.
So they give the same peak. And the carbon atom bonded to oxygen, this is a different environment. So it gives another peak. And which carbon gives the chemical shift at about 200, more than 200? about 205. So now you can use this table to find out which carbon gives a chemical shift of 205. You can just search in this table.
Aldehyde or ketone?
Oh, yes. Here. Aldehydes or ketones. COR. This will give a chemical shift about 190 to 220. So CO, this carbon, gives a chemical shift at 205. And CH3 groups give the chemical shift of about 30, right? You can just search
Yeah.
the table. Yeah. Okay, so you need just to learn how to use this table and find the different types of carbon and their different chemical shifts. So this is propanol. And next, let's see propanol. Its carbon-13 NMR spectrum look like this. You can see it. How many peaks?
3 peaks.
Yes, 3 peaks. So related to the display formula. How many different carbon atoms in
3.
different environments? Yeah. CH3, this is one, and CH2 in the middle. This is another, and COH. So CH3, it's at chemical shift about 5 to 40. You can just search the table. So CH3 group at chemical shift at 5 ppm, and CH2 at 37, and CHO group, you can just search it in the table. It's aldehyde, so it's at the chemical shift 205. So, and here is a study tip. The heights of peaks in the carbon-13 NMR spectra, they are not significant. The most important is their chemical shift values. Okay?
Yeah.
Here, okay. Let's just do an exam question. The first one. Okay, 1 minute to think about.
There's 1 peak because
Oh,
the 2 carbons have the same environment.
yes. This structure is symmetric. They are the same. Okay. Second question. Which is which?
First one is propan-10.
Okay, yeah. Because it has explain your answer.
The 3 carbons all have different environment.
Oh, yes. Okay, 3 peaks. It means that this substance has 3 carbon atoms in different environments. Okay. So this is propan-2OL, right? two peaks mean that there are. Okay, you can explain in your own words.
Because it is symmetrical, the two carbons on the outside have the same environment, and the middle carbon has a different environment.
Yes. Okay, great. 那我们就先上到这里，感觉你基础的知识掌握的都挺好。
好的。
好，OK，see you later.
Yeah, see you.
OK.